And we're back. We are on the second page of your worksheet. The directions tell us, let's try identifying different types of chemical sentences. Match the pattern of compound and element to one of the four types seen above. This used to be at the bottom of the previous page. Then I had to move it. So if we look at this sentence right here, I see a compound and a second compound, and a third compound, and a fourth compound. I see no individual atoms on any of these. These are all compounds. I have an element here and an element here. They're stuck together. An element here and an element here, stuck together. On the other side, my elements have switched partners. But I have elements on both sides. If you flip back to the front page, notice that the first of our reactions, I have element plus element yields single thing. Nope, that's not what I got. My second one says two things together yield two things separate. Nope, I'm looking for four compounds. Single replacement has two things together. Well, that's a compound, but my second thing's an element. Nope, I need all compounds. Double replacement, compound, 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 compound. Hey, looks like it's a double replacement. You might be thinking that perhaps it is a combustion reaction, but a combustion reaction has to have that carbon and hydrogen molecule and the oxygen gas. Without that, it is most definitely not a combustion. So this reaction here, this type of chemical sentence, is a double replacement. Let's try one more together. Let's look at, which one should we do together? Let's look at number 9. Down here, number 9. Number 9 has one big thing on the left and two smaller things on the right. Let's flip back to our front page. I need one big thing on the left and two small things on the right. Let's start at the top again. Synthesis, have two things on the left. Nope, that's not what I was looking for. Decomposition, one thing on the left, two things on the right. Hey, that looks good. So this one here is a decomposition. Take about 10 minutes to answer the 8 that have not yet been done on this page. Mr. or Mrs. Substitute, will you go ahead and pause the video? For after the pause, I will put up the correct answers. All right, hopefully by now you have gotten through all 10 of the first ones. Here are the correct answers. So we did number 1 together. We said it was a double replacement because I had compound, 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 compound. Number 2, once again, compound, 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 compound means it is, again, a double replacement. Anything with 4 compounds is a double replacement type of sentence. Number 3, same deal. 3 compounds makes it a double replacement. Number 4 has 2 single things coming together into one big one. Makes it a synthesis. Number 5 has a compound with an element. Single replacement because only one element is switching partners. Whereas number 6 has all of my compounds, both of these here in the beginning, switching partners. Makes it a double. Number 7, I have one thing breaking down into 2. Makes this a decomposition. Number 8, 2 things separate coming together as a synthesis reaction. Number 9, one big thing breaking down into 2 smaller ones makes it a decomp. And number 10, compound element with only one thing switching places makes this a single replacement. So hopefully you're beginning to see how to identify different types of chemical sentences. The next section asks you to translate full written out chemical reactions from that full written out form into symbols. So the directions say, for the following chemical sentences, translate each name into symbols, then determine the type of sentence. So there are a couple of words that are not chemical compounds but still require translations. Things like reacts with or and, to produce, to form, to yield. So anytime you see the words reacts with, you're going to put a plus. Anytime you see the word and, you're going to put a plus. Anytime you see the words produce or to form or to yield, you're going to put an arrow. So let's do the first one together. My first compound that I need to translate right here, copper 2 bromide. The symbol for copper is Cu. He has his 2+ charge here. The symbol for bromide, is Br, and he has a -1 charge. 2 minus 1 does not equal 0, so this is not written correctly just yet. I need more negative, so I'm going to have to multiply my -1 by something to get it to 2. That something is a 2, so I put a subscript as a 2. Next, I have the word plus, so guess what? We're going to put a plus. Here's my next element, my next compound that I need to translate. Symbol for sodium is Na. He has a +1 charge. Hydroxide has an OH charge, and he has hydroxide, his symbol is OH, and he has a -1 charge. It's a poly, so I put it in parentheses. There's my next word, to produce. To produce, remember, is replaced with an arrow. On to my next compound that I need to write. My next compound is copper 2 hydroxide. So copper 2, same as last time. Hydroxide has a -1 charge. 1 plus 2, -1 plus +2 is not 0. I need to multiply this -1 by something to get it to 2. So I need 2, gosh darn it, I need 2 hydroxides. Now notice, on the left side of my arrow there was no 2 by the hydroxide. Remember, the only time that subscripts get to move from one side of the arrow to another is when they're part of a poly. And this 2 out here is not part of a poly. I had to decide on that 2 based on the balancing of my charges. All I'm doing is translating. I apologize, there's a typo. There should be an and right here, which puts in a plus. Here's my last compound, sodium with his charge of +1, bromine with his charge of -1, 1 plus -1 equals 0. So this, let me go back over here. All we did was translate the words into chemical symbols. Now that I have all my chemical symbols written, I can stop and think, what type of reaction is this of my 5? I have compound, 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 compound. 4 compounds. And the only one of my 5 that had all 4 things as compounds was my double replacement. Let's do one more together. Let's see, which one should we do? Let's pick a good one. Let's do number 4. Number 4 said strontium iodide reacts with potassium sulfate to produce strontium sulfate and potassium iodide. So off we go translating. Sr, he has a 2+ charge. Iodide is a 1-. Reacts with, there's my word, that's the plus. Potassium sulfate, K +1. Sulfate is a poly, SO4, 2 negative. 2 negative plus 1 does not equal 0. Got to multiply my +1 by 2 to get to 0. To produce is the arrow. Strontium is 2+. Sulfate is SO4, 2-. 2 plus -2 equals 0. Good to go there. And there's my plus. Potassium iodide, K plus 1, I minus 1. 1 minus 1 equals 0. So again, notice my 2 on my K did not cross the arrow. That is not part of a poly. That 2 does not get to come. The 4, however, SO4, you can find that on your ion sheet. It actually says SO4. So that one gets to come. What kind of reaction is this? Compound, 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 compound. This is another double replacement. On the next video, I will put up the answers. I will show you the answers to all of these problems. Best of luck in translating.